Welcome to the fascinating world of topology. Topology is about the properties of shapes and spaces that stay the same even when you stretch, bend, or twist them. Get ready to explore how mathematics views shape and space in a unique way. So, what exactly is topology? It's the study of properties that don't change when you continuously deform objects. Think of it like this. You can stretch, bend, and twist a shape, but as long as you don't cut or glue it, its topological properties remain the same. For example, a circle can be stretched into a square, and from a topological perspective, they're considered equivalent. Let's look at some key concepts in topology. First is continuous deformation. These are transformations that preserve how things are connected. Think of it as reshaping something without cutting or gluing. The second concept is homeomorphism. This is a special kind of continuous function between spaces. It means that you can transform one space into another and back again continuously. Now, let's talk about topological equivalence. Shapes are considered topologically equivalent if you can deform one into the other without cutting or gluing. For example, a circle, a square, and a triangle are all topologically equivalent. However, a circle and a figure 8 are not equivalent because you can't turn a circle into a figure 8 without creating a hole. Topological invariants are properties of a shape that remain unchanged, even when you deform the shape. One example is the number of holes in a surface. This is also known as the genus of the surface. Another topological invariant is connectedness. This refers to whether a space is in one piece or multiple pieces. Let's explore some famous examples in topology. First, we have the Möbius strip. It is a one-sided surface. Imagine taking a strip of paper, giving it a half twist, and then taping the ends together. You'll create a surface with only one side in one continuous boundary. Next, we have Klein bottle. It has no inside or outside. It's a closed surface where the inside and outside are the same. If you were inside it, you could move around endlessly without ever crossing a boundary. Topology isn't just abstract math. It has many real-world applications. In physics, it's used in quantum field theory and string theory. In biology, it helps us understand DNA structure and protein folding. And in computer science, topology plays a role in network analysis and data visualization. So, in summary, topology studies shape without considering size. Topological invariants are the properties that remain unchanged, and topology has applications across many fields. It's all about continuous deformation. A circle is topologically equivalent to a square and a triangle. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.